Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about Leetcode question number 74. Search a 2D matrix. You are given an m cross n integer matrix with the following two property. Each row is sorted in non-decreasing order, which means each row are sorted in ascending order. The first integer of each row is greater than the last integer of the previous row, which means what they are telling us that this entire the first row, see here, this first row elements are lesser than the first element of the second row, then obviously the second row elements will be always greater than the first row element. So that's the important property you want to know about this question. Okay, now given an integer target, return true if target is in the matrix or false otherwise. So you must write a solution in O log of m cross n. So we can be doing this, but still first we can see the example. So see here, if this is the matrix and they have given the target is 3, then you will be just returning what? True, because 3 is there, right? Okay, now if this is the matrix and they have given that 13, whether 13 is present, no, then we will be returning false. So this is a simple problem statement, so straightforward. So first thing that comes into our mind is always brute force approach. Okay, so how we are going to do a brute force approach? So it is so simple. First of all, you want to going to traverse each and every element in the matrix. So first of all, I am at this particular index. Okay, so 1, whether 1 is equal to the 16, no. Now go. Whether 3 is equal to the 16, no. Whether 5 is equal to the 16, no. Whether 7 is equal to 16, no. Whether 10 is equal to 16, no. Whether 11 is equal to 16, no. Whether 16 is equal to 16, yes. Yes. So this time I will be returning what? True. Can I understand this? If after traversing the entire matrix and I didn't found out the target value, then what should I return? There I will be returning false. Can you understand this? Okay. Now what is the time complexity? It will be O of m cross n, and space complexity will be O of 1. Okay, where n is the number of rows and m is the number of columns. Okay, so this is how the time and space complexity will be for the brute force approach. Now we want to optimize it, right? So how we are going to optimize it? So what is the property that this problem statement has? So let me take this. Yes. So the property it has is all the elements in a row are in an ascending order, which means see here, this 1 3 5 7, these are in an ascending order. See here, 10 11 16 20, so these are in ascending order. 23 30 34 and 60, these are in ascending order. So each and every row are in an ascending order. Meanwhile, see here, this 10 is greater than its previous row. Meanwhile, this 23 is greater than its previous rows. Can you understand this? So these are the two property that they have given, and this is so much important. Okay, because I can tell you that it is in a sorted order. Whenever it is a sorted order, we can go with a binary search, right? So you may ask how we are going to do a binary search in this matrix. We don't know, right? So even if you don't know about the binary search, you can also do this. You can also do this question. You can build a logic. How? So see here, listen this carefully. This is going to be more precise, which means you want to know about this and it is much easier than you think. Okay, but it is a bit tricky. Okay, so see here, let's take target is equal to 16, same 16. Okay, now I am at this particular point 1. Okay, so now I have two choice. What are those two choice? Either I can go to this cell or I can go to this cell. You know, right? Whether we can go to the right side or I may go down. Okay, which is the best choice? I know, because see here, if I go down, I will be going down, right? Because see here, it is 10. Obviously these rows will doesn't have 16. Yes. So that's the reason why I am going to down. So I'll be going to down. So now I am at this particular point. Okay, now I can either go to down or I can go to right. Which place I will be going? I'll be going to right, because what is down value? It is 23. 23 is greater than 16. 23 is greater than 16. At this particular point, I will be just going on to the right side of this index, this 10 index, and checking whether there may be a possibility of 16. There may be a possibility. That I am not telling that surely there may be a possibility. So go to this 11. Okay, again for this 11 also I can go to down and right, whether I can go down or right. So down means it is 30. Whether 16 is greater than 13, sorry, is greater than 30. No, at this particular point I'll be going towards the right side. Okay, go towards the right side. So I'll be going towards the right side. So 16. So 16 is equal to 16. So at this point I'll be telling that it is true. Can I understand this? Okay. Let us see another time with another example. Now let us take the target value as 34. Okay, as 34. Okay, so initially I am at this particular point 1. Okay, now I have two choices, whether I can go to right side or I can go to down. So okay, tell me 10 is whether 10 is lesser than the 34. No, right? Which means 34 may be in this row or maybe in its downside at this particular points, right? So it is unnecessary to go to the right side. So I'll be eliminating to go to the right side and I'll be going to the downside. So when I'm going to downside, I'll be at this particular point 10. Okay, now again I can go to right side. Yes, down and right side, right? Now whether I can go down, yes, 23 is less than 34. So at this particular point I will be going again to the down. Can you understand this? Yes. So whenever I am going down, if my next row element is less than my target, then there is no purpose of, or it is unnecessary to check to its same row. I will be further go to the next row, right? Because it has a property like this 23 will be always greater than its previous row all elements, right? So that's the reason why I am going down simply. Okay, now I am at this 23. Whether I can go down or I go right. So see here, down there is nothing, right? So up to which I can go down, up to the last row I can go down. So if I put a I pointer for this row, I pointer, then whenever my I is less than my row minus 1, I can go to down as well as the right. Okay, if it is not, then I am supposed to go only to right. Okay, now 23, so go to right, 30, again go to right, 35, 34. So in this case I will be returning true. Okay, if take for example, next example is the same matrix, but the target value is something like 100. Okay, so first I'll be at this one. Now I'll be just checking the down value, whether this 10 is less than 100. Yes, then you will be going to this particular point. Now its down value is 23. Whether 23 is less than 100, yes, then go here. Again for this 23, whether I have down value, no, just go to right. For this 30, it's also not equal to the 100. Whether it has down value, no, then go to right. 34 has any 34 is equal to 100, no. Whether it has any down value, no, just go to right. Whether 60 has any down value, no, and also not equal to 100, then go to right. Unfortunately, we doesn't have anything. We reached what? We reached the end. So at this particular point, I can tell that it is false. Okay, now tell me what is the time complexity. So I can tell you that time complexity will be over log of n cross m, and space complexity will be over 1. Okay, so this is going to be the worst time complexity. Okay, the algorithm will be running in the worst time complexity of O of log of n cross m, and we didn't took any auxiliary space, so the space complexity will be over 1. So this is very optimized solution, right? So let us see the code so that it will be more clear. So I prefer Java code. If you want the C++ or Python code, you may get in the description. Okay. So see here, first of all, I will be tracking the row pointer and j will be tracking towards the column pointer. Okay. These both things will be equal to 0 initially, which means these both the current thing will be pointing towards this particular point. Fine. Now n is equal to matrix length and m is equal to matrix zeros length, which means n is equal to the row and m is equal to the total number of columns. Okay. Now while my I pointer should be less than the row and also my j pointer should be less than the column, then only I will be go on and looping. Okay. Now if my matrix of I and j is equal to target, just return true. That's it. That's it. Else what should I do? I have two conditions. If I want to check for the down value, right? For checking down value, my I should be less than n minus 1 to avoid the out of bound exception. The index should be in the range, right? So for that purpose, I am just using I is less than n minus 1 and matrix of I plus 1 and j is less than or equal to the target. So here what I am doing, I am just checking whether my down value is less than or equal to the target. If it is so, then I want to go to the down. Down means what? I plus plus. Else I want to go to the right side, which means j plus plus. When I am going to the right side, if I don't have any down value or my down value is greater than the target. It's greater than the target, then I want to move towards the right side. Okay. After finishing this entire loop, if I didn't encounter this particular condition, then what should I return? I should return false. Okay. Let me submit it. Yes, it is submitted successfully. To know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and subscribe to my channel, and don't skip any videos. Okay, basically in this playlist, because it is a binary search playlist. And if you have any doubts, just comment below. I'll be commenting out the answers. Thank you.